Hi folks, this is the solution to number 8 on page 60. So they give us this function and they want f to be continuous for all real numbers. Okay, now when we look at all values greater than 5 or less than 5, we know right away that we have continuity because this is a line and that's a parabola and those are continuous on their domains. Okay, so the only place where we really have to check is at x equals 5. Okay, so let's remember that to be continuous means that the limit as x approaches 5 of this function has to be equal to the function value at 5. Okay, so in this case here, the function value at 5 is actually given. So the limit needs to be equal to 8. But because it's defined differently on either side of 5, this is why we need to consider left-handed and right-handed limits. Okay, so let's start with the right-handed limit here, which is going to be using this top function. So if I take the limit as x approaches 5 from the right of f at x, well here, as we said, it's this function which defines the y values to the right of 5. So I'm taking the limit of ax plus 3 as x approaches 5 from the right. Okay, but here there's no nothing funny going on at 5, so this is just going to approach 5a plus 3. Okay, but again, if I need this to be continuous, this is going to have to be equal to 8 because both the left and right-handed limits are going to have to be equal to the function value. Okay, so from here we can determine the value for a because that's the only variable in there. So here, to bring that to the other side, we just have 5, so we have that a is equal to 1. Okay, so now we still have to determine the b value. So we'll hopefully get that by looking at the left-handed limit. So limit as x approaches 5 from the left of our function. Okay, well in this case here, it's this equation that defines the y values to the left of 5. So I'm taking the limit of x squared plus bx plus, well in this case here I've already determined that the a value has to be equal to 1. So I'll just put that in here right off the bat. And again, this is just an easy limit to take because it's just a quadratic. So this is just going to approach 5 squared plus b times 5 plus 1. Okay, and I need the left-handed limit to also be equal to the function value of 8. Okay, and so now I just solve this here. So here I've got 8 minus 25 minus 1 is equal to 5b. So here, what do we have? We have 8 minus 25 is, what is that? I guess that's negative 17 minus 1 is negative 18. Okay, and so b is just equal to negative 18 over 5. Okay, so b has to be equal to negative 18 over 5, and a has to be equal to 1. So just a quick recap here. Okay, we want this function to be continuous anywhere. The only place that has an issue is at x equals 5. Okay, so I start off with the assumption that my limit as x approaches 5 has to be equal to the function value at 5. And because it's defined differently on either side of 5, that's why I needed to use both right-handed and left.